okay? The speed of cars passing a supermarket. So there's like a police officer, let's say, outside of a grocery store, and he's or she are using their radar gun to calculate or record the speeds of cars going by. Maybe they're interested in whether they or not they need to put a speed bump or a stop sign or something there. And they determine, okay, it's normally distributed with mean 53.6 and standard deviation 7.4. And you actually do need both the mean and the standard deviation to work with a normal distribution. And the reason for that is that, you know, saying the mean is not just the mean is not enough. Like, you could picture like one normal distribution like this, and then if you had one with a smaller standard deviation, it could have the same mean. Oop, I took a bad turn there. It could have the same mean but be really skinny. Or if it had a really big standard deviation, it could have the same mean but be really wide. So knowing the mean alone is not enough to talk about a normal distribution. You actually have to know both the mean and the standard deviation. Kind of like in a binomial distribution, you had to know both the number of trials and probability of success. You needed two pieces of information to work with the binomial distribution. You need two pieces of information to work with a normal distribution. So I'm going to let x be the speed of a randomly selected car. And the way we write that x is a normal distribution, similar to binomial, instead of a b, we write an n. Okay. And then we say, okay, in general, what we want is the mean. And you say the variance, not the standard deviation. Really, the standard deviation is what we work with, but the conventional notation is to write down the variance. Okay, so we say x is normally distributed. The mean here is 53.6. That's the speed that most cars are, you know, that's their average speed. And the standard deviation is 7.4. We want the variance, so really we should write 7.4 squared. And you could square that out in your calculator if you want, or you could just leave it like this. And remember, because these calculations are mostly done in your calculator, one way of still earning some part marks if you accidentally mistype on your calculator, it is helpful to draw the diagram. Okay, just one sec, sorry. Sorry, my cat somehow opened the door to this room and was letting noise in. Okay, we've got the diagram here. We know 53.6 is the mean. Oh, my cat, sorry. Go, cat. Is attacking my screen. And the standard deviation is 7.4. And okay, so for part A, right, for part A, we want to know, okay, the probability of car is between 60 and 75. So 60 is somewhere here. I'm going to zoom in so I can draw a bit better. And 75 would be somewhere here. So really we want this area. Now, you don't have to draw these to scale to earn part marks, but you do, like, you couldn't put 60 to the left of the mean, for instance, because we know that 60 is greater than the mean. So as long as your two kind of boundary points for this area to the right of the mean, this will give you a mark if you accidentally put the wrong values into your calculator. Okay, so now we actually have to calculate these on our calculator. Okay, I'm actually gonna set up all of these three drawings, and then we'll go through how to calculate all of them on your calculator. Okay, so that's part A. Part B, you could have Again, our normal distribution. Here we want at most 70. So of course we have our mean here. 70 is to the left of the mean. If it's at most 70, that would put it this entire area. Right? That's what we want to calculate. And for part, let's see, let's call it C, because that's what it's called, we would have at least 60. So we've got 53.6 here. And there we would want to calculate this area. Okay? All of these can be done in your calculator. I'm going to show you how. Rahul, if you can do the binomial on your calculator, you should be able to follow along with this, I think, as well. It's accessed from a very similar place. So let me share my screen. Hopefully you're taking notes or you can jot these down because you won't be able to see my iPad screen when I'm on my calculator screen. Okay. Okay. So let's do part A first. Part A, we want to calculate the probability that our cars are between 60 and 75 kilometers per hour. So very similar to the binomial distribution. You're going to go second vars to get into that distribution menu again. And the normal stuff is the first options you see, which is nice. It's by far the most commonly used distribution, so they put it first. A word of warning, we are never going to use normal PDF, the first option. Remember, we're never going to calculate the probability of having an exact value for a continuous distribution. They're all considered to be 0. The only reason those are in the menu are if you want to, it's a command you can use to help graph the bell curve, but we're never going to actually use it. We're going to use normal CDF because we do want a range of values. We want to know the probability of being between 53.6, sorry, 60 and 75. That's a range. It's CDF. We're always going to be doing ranges. So we're going to hit normal CDF. And we can, this is a little bit nicer in some ways than the binomial distribution because we can put in the lower and the upper bound, right? So our lower bound is 60. That's the smallest car speed we're interested in. And our upper bound is 75. Okay. Our mean we know is 53.6. And our standard deviation is 7.4. And if we put this into our calculator, this will calculate that area under the curve for us. And we get that the probability that x is between 60 and 75. I'm just putting this on a note, you guys can't see it, is to 3 figs it, that sig fig 0.192. Okay, does anybody have any questions about how to use your calculator to get this area? No, this is the easiest situation where you know a lower bound, an upper bound, and the mean and the standard deviation. Is that a hand? Yep.
Is there ever a scenario where we wouldn't be given like the mean or the standard deviation in this case?
Yes, but that's not for today. That's for tomorrow or the next day.
Okay.
So for now, don't worry about it. That day will come, but you don't have to worry yet.
Okay, sure. Thank you.
Yep, no problem. Let's look at, okay, part B. So there we have, okay, at most 70 kilometers per hour. So what we're going to do, we're going to go second distribution again. We're going to go into normal CDF just like before. Now, we know our upper bound. Our upper bound is 70, right? Because they can go at most 70. Okay. The problem is we don't actually have a lower bound. And you might say, well, 0 should be the lower bound because you can't go any slower than 0 kilometers per hour. You know, not counting like negative velocities correspond to backwards motion. But remember, a bug, if you will, or a feature of the normal distribution is that it goes on forever, all the way to negative infinity on the x-axis. So what we do here is we put in just some really big negative number. It doesn't matter. Like, we can't put negative infinity into our calculator, but if you put something really big, it'll round to 3 sig figs to be the same answer at some point. So you put negative 10,000. Even if we put 0 in, 0 is so many standard deviations away from the mean that probably we get the same answer anyway to 3 sig figs. But in general, you should put in some very large negative number, or very small number, if you will. So again, we can paste it. Oh, syntax here. Oh, I switched the lower and upper. Did I? Yes, this should be negative. Our upper is 70. My apologies. I heard a hand raised. You can go ahead.
Yeah, that was what I was going to say.
Okay, you're catching my error. Thank you. So I paste that in. What? Okay, I don't know what, that's weird. Okay, normal CDF. It should all be fine. 53.
Do we have to use the negative sign for the 99?
Yes, you do. Yes, and the computer, it always puts it. You're right. Thank you so much. You have to put the negative sign. I would remember that on the handheld calculator, but on my computer, I can't just hit minus. Thank you. That is exactly what it is. There we go. So there is a 98.7% chance that your speed is less than 70 kilometers per hour. So this is probability x is less than 70 equals 0.987. Okay. Is everyone okay with this? Okay, so we are going to then do the last one. Very similar. This is normal CDF. Here we're saying at least 60. So our lower bound is 60. And for our upper bound now, we just put in some really big number, because you can't put in infinity. Or you can put in 10,000. Something like that. It won't matter. And luckily our calculator, it remembers the mean and standard deviation for us. I'm going to paste that in. We get here that the probability that x is greater than 60 is equal to 0.194. And that is how to use your calculator. Any questions with the calculator before I switch back to the iPad?
This isn't very related, but will we ever have to extrapolate or interpolate a point on the curve?
What do you mean by that?
Like find a point on the curve and what the value would be there.
No, you will not. Okay. So I'm switching back to the note. Okay, for some reason that didn't work. Give me one more sec. Okay. Okay, so you can see I've written in the answers. Those are directly from my calculator.